Welcome to ClickMyProject.com. The title of the project is Textual Sentimental Analysis using lexicon-based approaches. And the abstract of the project is nowadays the advance of social has led to the explosive growth of opinion data. Therefore, sentimental analysis had attracted a lot of attentions. Currently, sentiment analysis applications are divided into two main approaches, the lexicon-based approach and the machine learning approach. For the lexicon-based approach, it requires a sentiment lexicon to determine the opinion polarity. We propose a framework to automatically generate sentiment lexicon. First, we determine the semantic similarity between two words in the entire unlabeled corpus. We treat the words as nodes and similarities as weighted edges to construct word graphs. So, we propose a VADER sentiment to define the polarity score for the unlabeled dataset and find the intensity of the text. After the labeling the dataset based on polarity score and then selecting the independent model and dependent model, then splitting the dataset into training dataset and testing dataset. Finally, the classification technique implementing deep learning algorithm like enhance long short-term memory neural network and generate the result based on matrices like accuracy. And the flow diagram of the project is first we need to select the data. First we need to select the dataset as the social media data. So then we use the sample data in our console working directory. Then it will apply it into pre-processing. In pre-processing we are going to clean our dataset. In also pre-processing we are going to check the description and information about the dataset, and it will move into VADER sentiment analysis. In VADER sentiment analysis it will find the sentimental polarity score based on the text contained in our dataset. Then it will move into tokenization, which is used to convert the text into sequences and splitting the larger text into smaller lines. Then it will be implemented into data splitting. In data splitting we are going to split our dataset into training dataset and testing dataset. Then it will be applied into classification. In classification we are using two algorithms, one is multinomial naive-Bayes algorithm and another is long short-term memory neural network deep learning algorithm, and finally generate the result in the form of matrices like accuracy and also validation accuracy. Then finally I have to compare the performance between the machine learning and deep learning algorithm. The program was successfully executed in Anaconda Navigator Spider ID, and this is the sample dataset of our lexicon data. After that I have to check the description about the dataset for every columns. In that it will show the results based on count value, unique value, top value, frequency value, mean value, standard value, minimum to maximum value for every columns contained in our dataset. And then I will check the information about the data types from our dataset columns. Then I have to check the polarity score based on the textures for applying the sentiment. In that I have to apply 5 sentiments like negative, positive, neutral and strongly positive and strongly negative. And then I have to plot the count visualization of the negative, positive, neutral, strongly positive and strongly negative. Then I have to apply the NLTK. In that I have to check the overall vocabulary size is 33,751. After that I have to apply our dataset into tokenization and parallel sequential. This is the sample result for the single test, and this is the input text, and it is the tokenization result. In tokenization it will convert the text into sequence, and this is the padding result. In padding result it will padded the tokenization result based on their indexes. After that it will check the number of unique tokens. In our dataset contains overall 33,715 unique tokens, and after tokenization I have to split our dataset into training dataset and testing dataset for classification. In classification I am using machine learning algorithm as well as deep learning algorithm. In machine learning algorithm I am using multinomial naive-Bayes algorithm. The multinomial naive-Bayes algorithm accuracy is 53%, and this is the bidirectional long short-term memory neural network algorithm summary result. This is the summary result of BiLSTM algorithm, and this algorithm which is extract the overall trainable parameter is 17,76,869. These parameters are in trainable form, so I have to train the dataset based on the trainable parameter in 4 different training epochs, and it will provide the result in based on accuracy. Like our LSTM algorithm, bidirectional LSTM algorithm provides 84% of accuracy, and this is the performance graph for training accuracy and validation accuracy, and training loss and validation loss for our bidirectional LSTM algorithm. After that, I have to compare the multinomial naive-Bayes algorithm performance versus LSTM algorithm performance, and these are all the variable results that we are obtained from our program.